Hi, I'm Lana and I enjoy trying to convince AI researchers to do ALife. First, let me tell you a bit about myself. I started my life as a researcher by doing good old-fashioned AI. You choose a task, you have an idea about how the task should be solved, you define a mathematical model, and you put that model into a device, whether it's a robot, a computer, or a mobile phone. My first ALife project was quite different. We took some rats' neurons, mixed them up, put them inside a robot, and tried to see what kind of task we could teach that robot. I worked on the simulation side, and my job was to find how to convince the network to learn something without a reward. You can already see that there is quite a difference. We didn't start with the task, and we didn't know how the neurons worked. This is the kind of research that I do now. I try evolving visual illusions, I try to recreate the tree of life from scratch, or I put parasites in cellular automata to make them grow a third eye. Now you might notice that there is no immediate application to this kind of project, and you might wonder if there is even a point to doing this kind of research. My goal with this talk is to convince you that doing AI with the flavor of ALife can give you a broader starting point and at the same time be more relevant. So why did I go from doing concrete engineering projects to doing the more abstract type of ALife research? There are several reasons. I think everyone has their own reasons, and these were mine. The first reason is that I don't want to tell my AI how to do things. This is not a controversial view anymore. Most people just specify the task, what the AI should do, and we don't tell it how to do it. But I also don't really want to tell my AI what to do. Ideally, it would just surprise me. I find that way more interesting. Another reason, and I know I'm in the minority with this, but I don't care that much about human intelligence. I'm way more interested in other kinds of intelligence, including alien intelligence. Actually, one of my current projects, in collaboration with NASA, is to try to find alien life. And there are many more pragmatic reasons, including the fact that I don't want to do what everyone else is doing. Partly because I want to be original, and partly because I don't like strong competition. I would rather be in my own space with a few people doing our own thing. Shameless promotion. If you two are more interested in collaborating than in competing, please become a beta user of my open collaboration platform called Mimosa. Just contact me at this email address. For the main part of the talk, let's start with some basics. Artificial life, also known as ALife, has three main subfields, to which I would add a fourth, art. First, we have wet ALife, where the philosophy is that we know one example of life, and so the fastest way to make artificial life is to use life stuff and combine it in new ways. Hard ALife doesn't use the physical components of life, but they know that the real world might still be your best bet to try to evolve a new life form. Hard ALife is at a different scale than wet ALife. If you do wet ALife, you're probably at a micro scale, or at least a pretty small scale. If you want to work with bigger components, you have to go to hard ALife. Everything that is robotics belongs to hard ALife. Now soft ALife, which is where most of AI belongs. We try to make life in made-up worlds with made-up parts, which is of course much more convenient than dealing with the real world and all its noise, but you can probably see the danger here. We have the risk of becoming irrelevant. If you use toy tasks in toy models, there is no guarantee that whatever you find will be related to real life. But in a way, that's also a good point, because you're not limited by real life. Nothing says that we can't have life in a world that is completely made up with different dimensions and different laws. AI is mostly in soft ALife, but not only. In the rest of this talk, I will explain why AI should care about ALife and why ALife should care about AI. I will also talk about the difference between ALife flavored AI and deep learning. And finally, I will present some big open questions in this field and give some examples of papers. Speaking of papers, if you want to keep up with new published ALife papers, please follow this Twitter account, ALife Papers. We are also looking for volunteers to help curate the content. I talked a bit about why do ALife if you're an AI researcher. I would also like you to imagine the opposite. Imagine you're an ALife researcher. Why are some good reasons to do AI? The first reason is that life and intelligence aren't that different. They are very close phenomena. One of the most important aspects of life is adaptation. Finding solutions to problems, getting used to new environments, making the best of what you have. Intelligence is also about adaptation and finding solutions to problems and adapting to new environments. If you're interested in life, you should also be interested in intelligence and vice versa. Or you could take the opposite point of view. Intelligence is only a property of life. We don't know examples of intelligence without life. And I could also argue that anywhere there is life, there is also intelligence. So what better way to prove that you've built artificial life than to prove that you've evolved intelligence? Intelligence and life are linked. Any advance we can make in one field will resonate in the other. If you ignore one, you risk missing the big picture. Finally, if you're not interested in AI because you don't like neural networks, you don't have to work with neural networks. You can do AI without neurons and even without brains. Not your uncle's deep learning. First, why did I say uncle here? Well, deep learning is not a baby anymore. It matured very fast and now it's a grown-up. But somehow it's still cool. It's not easy for a mature field to continue to attract young researchers. And deep learning managed to do that. So deep learning is a bit like your cool uncle. Here is an exchange that I saw on Twitter, and if I could, I would give those guys an Ig Nobel Prize, because this made me laugh, and then it made me think. First guy says, life evolves on a planet where survival depends foremost on doing correct completion of text snippets. Is the end result intelligent? He's of course referring to the fact that a lot of deep learning deals with text completion. Do we really want to call this intelligence? And the other guy says, life evolves on a planet where survival depends foremost on doing correct completion of shape rotation. He is referring to IQ tests. A big part of your IQ score will depend on Raven matrices, where you have to rotate shapes in your head. There are two ways you can take this. The first is, well, obviously survival on Earth doesn't depend on this, but that's how we measure intelligence. So maybe we don't have to optimize for intelligence to get intelligence. The other way to say this is that IQ tests don't actually measure intelligence, and so I don't know what we're measuring, but maybe we should focus on something that is more relevant to life. Here are two archive searches side by side. On the right, I search for neural network, and on the left you have artificial life. If you look at the results, neural network research is mostly focused on applying deep learning to engineering problems, while the results for ALife are more diverse and mostly don't even mention deep learning or any kind of application. One of the reasons for this difference is that deep learning is in an exploitation phase, and ALife is still in exploration. Both phases have pros and cons, but ideally you would have a balance of the two. Now I'm going to list some of the big open questions in AI as a function of ALife. First, the definition of intelligence from a life point of view. What is intelligence? Is it the correct completion of shape rotations? If not, what is it? If we want to answer this question, we have to focus on intelligence besides neurons. For example, plant intelligence, or bacteria, or aliens. Second, the origins of intelligence. Now there is a big sub-part of ALife called Origins of Life research. This is the equivalent but for intelligence. Where does intelligence come from? What is in between adaptation over several generations and adaptation during the lifetime of an agent? Third, open-ended intelligence. Again, in ALife there is a big topic called open-ended evolution. This is the equivalent but for intelligence. Can we build agents that learn without being told what to do and that can learn all of their lives? 4. The role of embodiment. You are not a brain in a vat. How much does your body influence what you can learn? And exactly what is it influencing? I will give example of papers for these 4 questions, but here are 2 more questions. The pet distance question. So the pet distance is the fact that when you have a pet that you find very cute and interesting, and they do something you don't understand, your first reaction will not be to run and get a knife and cut them open to see how they work. If you give me any kind of neural network that does something interesting, my first reaction will be to open it and change what's inside. Can we make an AI that is so interesting and likable that people will not want to immediately open it? This might seem like a trivial question, but it's linked to very big issues. For example, can you make an intelligent toy that lasts for 100 years? Now let me tell you, 99% of the algorithms that you use now and call AI, in 10 or 20 years, nobody will care about them, nobody will know how to use them, the hardware will be obsolete, the functions will be deprecated, and just no one will find it interesting, no one will care. If you gave me a really smart pet, I wouldn't get bored in 100 years. So what is missing? When you think about this question, you focus on totally different issues than classical AI. For example, what does interesting mean? Can this toy learn things for 100 years? How do I make it not too reliant on human input? Even if you believe that it's only about emotions and caring, it's still pretty hard to make an algorithm that people have emotions towards. And 6. AI for biology and life applications. Can AI help us create life? Can AI distinguish life from non-life? If you are interested in that last question, I encourage you to visit this GitHub page, where Olaf Witkowski and I organized a fake life recognition contest. Okay, now for the papers. First, the definition of intelligence. This is way broader than most people imagine. For example, this plant, the Venus flytrap, can count up to 3. If you touch it just once, it will not close. You have to touch it 3 times. Does that qualify as intelligence? Just below, the Mimosa pudica plant has memories. It can learn which situations are dangerous and which are not. Is this intelligence? On the right, the Bocchilla trifoliata plant can imitate the shape of its neighbors. It can somehow sense the shape of other leaves, and then it modifies the shape of its own leaves to look like the other plant. Is this impressive enough to qualify as intelligence? Or take this famous video of a white cell chasing a bacteria. It can clearly make decisions, it has a goal, it moves around. Does this mean that you have little intelligence agents going through your veins? 2. The origins of intelligence. I recently found this very interesting paper by Geoffrey Hinton and Stephen Nolan. The paper is called How Learning Can Guide Evolution. And what they show is that when a task is very difficult to solve just using evolution, adding the possibility to learn can actually influence the evolution and guide it towards the right solution. I think it's a good example of motivation why learning on a lifetime scale could have evolved. 3. Open-ended intelligence. Open-ended evolution is not about can you evolve forever. It's about can you make a simulation that evolves forever and is also interesting forever. Not just evolving the same 3 things over and over. In the same way, open-ended intelligence is not just about can you learn forever, although it's part of the problem. It's more about can you get interesting learning forever? First, learning forever probably means that you don't want to be specifying the task over and over again, so the AI will have to decide on its own task. So the question becomes, can you get interesting forever learning without specifying the task? Part of the solution will probably involve finding the right reward functions. In this paper called Genetic Programming for Reward Function Search, they try to evolve the reward function. What we usually do when specifying the reward function by hand is to make the fitness and the reward match. And they find that on this specific task, the fastest way to learn wasn't to match the fitness and the reward. And it turns out that the best reward function gets close to a concept called empowerment. Basically, you want to reward the agent for having choices. Last paper about the role of embodiment. Much of the focus of AI is on the brain. We are humans, we like brains, but you can do a lot even without a brain. This robot is controlled through springs that you contract or expand, where each spring only knows how much tension is on it and has to react by contracting or expanding. They show that the gates that you can obtain using a central controller can be precisely replicated using a distributed controller without a brain. This is the end of my talk. I hope I could convince you that AI is a function of ALife, that it can be convenient yet stay relevant. It has a lot of convergences with mainstream AI, yet it has its own flavor. It's about more than neurons, more than brains, and more than humans. I hope we can move on from Raven matrices and instead focus on adapting to different environments and using the connections between these environments.